Hey guys, today we're going to focus on constraint optimization. Now if you think that you will never use this in real life, you've got it all wrong. We're going to be talking about budget constraints. Especially there are two types of constraints, equality and inequality constraints. But we will focus on equality constraints. In order for you guys to solve this, you'll need a Lagrangian function. So for budget optimization, we're going to be focusing to find the maximum of a function. Let's call it f of x and y. And we're going to find the constraint of it subject to h, x, y at k. So in order for us to do this, we need to first create a Lagrange function. So when creating a Lagrange function, you first of all define the Lagrange function L for x, y, and lambda. So in our case, that's f of x and y minus lambda h of x and y minus k. In this case, I'm highlighting both the lambdas in blue. Those are called the Lagrange multiplier. So second of all, we're going to find the partial derivatives of our Lagrange function according to x and y and lambda. So the derivative of the Lagrange function in respect to x will give us fx minus lambda hx. Whilst in respect to y, that would be the derivative of f in terms of y minus lambda hy. Deriving the Lagrange function in respect to lambda will give us the function of h, which also equals to k. Remember, lambda is by how much does the optimal value change if you relax the constraint by 1 unit. Now we have to set the derivatives in respect to x and y equal to 0 and solve the system of two equations. That's it with the theory. Let's make it clear with an economic application. Let's consider the utility function of candy and sodas, C and S. The function would be u of C and S. We define the function as C times x for the consumer Nico. This is Nico. Nico wants to get the highest utility out of these goods, respecting the budget that his parents gave him. Let's say he has a budget of 200 euros. So essentially we're trying to find a combination of candy and soda that maximizes Nico's overall happiness. Let's consider the cost. Each candy, each unit of C, costs 1 euro, whilst each soda, each unit of S, costs 2 euros. So when we build the constraint, we take into consideration the 1 euro that each unit of C costs, plus the 2 euros that each unit of S costs. Overall, that can equal 200 euros maximum. Now we can create a Lagrange function. L is equal to C times S minus lambda times the constraint. Now we derive the function in terms of C, S, and lambda, giving us S minus lambda, C minus 2 lambda, and C plus 2S minus 200. Now we set both the partial derivatives equal to 0. That way we get lambda equals to S, and lambda also equals to C over 2. Therefore we can derive that S is equal to C over 2, or that C is equal to 2S. Now we can replace the constraint, giving us C plus 2S is equal to 200. From our previous equations we obtain that 2S plus 2S is equal to 200, giving us S equal to 50. Plugging in our result of S into the previous equations, we obtain C is equal to 100. To maximize his utility, Nico will go to the candy store and buy 50 cans of soda and 100 bars of candy.